All right, well, I'm going to get started. This is our last lecture. There will be any more lectures. Well, I'm not sure about the yes part because, I barely have enough time to cover the topics that I think I should cover in this class. Because, I want to make sure that you guys can take information or take the knowledge from this class and be able to apply that the next time when you write a C program or C program. And when your program doesn't do what it's supposed to and mysterious stuff starts to happen, at least you will have some tools to help debug the program. The other day, I was just talking about this in the lab, and probably a few people showed up and actually figured it apart. But basically, when your stack frame is corrupted, depending on where the corruption happens, it can cause problems that will be nearly impossible to diagnose unless you have a good understanding of how the stack is used in C and C++. So what I'll do is I'm just going to give you a quick idea of what is going on and what can happen. So let's say this is high memory and this is low memory. We know that the stack grows lower as we continue to use it. So you have basically stack frames upon stack frames upon stack frames on the stack. And how deep or how many levels of stack frames you can stack depends on the complexity of your program. So you can have main calling a particular subroutine, that subroutine calls something else. So you can basically get down to easily 5 to 10 levels down by the time it gets to the subroutine that you are trying to debug. Okay. So are there any questions about this picture? Okay. Within each call frame, we have certain things that are common. So within each call frame, we have optionally parameters because some subroutines do not have parameters, which is okay. After parameters, we have the return address because the return address is basically quote-unquote pushed by the call instruction. After that, as a convention in GCC, and I think the same applies to other compilers as well, would be the old frame pointer. Okay, so we save EVP or the value of EVP right under return address, and then below that we have our local variables. Okay, and then below the local variables we have some miscellaneous stuff like saving registers and stuff like that. Okay, so the call frame looks about like this for every single subroutine. So when you are down here, okay, so let's say this is the call frame of the current subroutine, okay, and you have, you're using a pointer or you're using a local array, okay, that is defined locally, and your index is out of whack, okay. It's not very difficult for an index to go out of whack, okay, and I'll illustrate later on, how you can get an index to go out of whack. So if you have a local array, let's say here, and somehow the index is so far off that instead of modifying an entry here, you're now modifying an entry all the way over here. It's entirely possible, okay? C and C++ does not, give you any type of limitation. In Visual Basic, every array has a size that is inherent to the array itself, and every time you want to access an array out of bound, it gives you a runtime error. Okay, it stops right away and say, hey, on this line, you're trying to access an array out of bound, and you cannot do much damage at that point, which is good. But C and C++ doesn't do that. Okay, so instead, inside this subroutine, you now modify the call frame of somebody else. So depending on what you're modifying, things can, the symptom can be very different. So it can range everything from a local variable that is one of your callers getting modified for no particular reason to changing the frame pointer. Now, when you change the frame pointer, okay, let's say we're changing the frame pointer, the same frame pointer here. So no symptom will show up all the way up to here, and this particular subroutine is not going to have any problems either. But when this subroutine returns to this guy here, the frame pointer is restored to the caller, and now the caller is using the wrong frame pointer. It would be a good thing if that frame pointer is completely off, okay, like 0, because it will just cause a segmentation fault right away. If that frame pointer is off by just a few bytes because the modification is increment by 4, decrement by 4, or some insane stuff like that, then that frame pointer, as far as this subroutine is concerned, EVP is almost right, except it is off by 4. every time you access variable I, it's actually accessing variable j. Every time it's supposed to access variable j, it's accessing variable k, and so on. So things will look completely mysterious from the perspective of you as a high-level language programmer. Okay? So when you get back to that point and you notice something bad has happened, you are so far off from where the problem happens. Are you getting my point here? Okay. So if you don't know, if you don't understand how everything is organized and how array is accessed, then by the time you get back to this subroutine, there's nothing that can explain why the variables, quote unquote, have shifted by one variable up. Is that making any sense to you? And that's one of the worst things that can happen is, how come my variables are off by one variable? Is it the compiler's fault? No, it's the same compiler. And who is the faulty party? Most people will suspect something here, or maybe something at a cost. Seldom will people consider something all the way down here. And that's why the understanding of a call frame and also how various data structure is accessed is actually very useful when it comes to debugging C and C++ programs. Now, if you say that attack, I will never program in C or C++, I will only program in a scripting language, then I got nothing to say. I cannot respond to that. Yep. Yep.
If the parameter is a pointer and it's pointing to a stack.
Yeah, the parameter can be a pointer pointing to somewhere else on the stack.
Okay, and if it's pointing to pnext, is the value for above it or for below it?
I do not understand that question.
You know how each node has a value component and a pnext component?
Yes.
If the pointer's pointing to pnext, how far is value to pnext? How do we access value?
Well, that's a good question. Okay, so it does not depend. Okay, it should not depend, or you should not depend on that particular offset. A node looks like this in this class, and this is also a good time to kind of visualize, all the various components of the program that you need to implement for LList or the sorted list. But this time, I'm going to use a picture to illustrate. So what you're dealing with here, this is also a picture that I used, in the lab, in the previous lab session. Okay, so what we have here is this is a struct node, and that will make this a struct node pointer, and that will make this a struct node pointer to a pointer. Okay, so what happens is this is a 4-byte thing that is pointing to this guy here. In other words, this 4-byte thing contains the address of this 4-byte thing. This 4-byte thing in return has the address of the lowest byte of a struct node. Now, once you get to the lowest byte of a struct node, then you can access the individual members. Because the individual members, one is called value, the other one is plist. It doesn't even matter which one is which one, okay? So I can have I think one is called pnext, and the other one is called value. It doesn't matter which way is which way, because your program should not depend on that order at all. Okay, let me just go back to the homework assignment because I did one little edit at the end of the homework assignment description, and I just want to emphasize that, just so that you are aware of it. Your code should rely only on the definitions of the include file. The node.inc include file is what you need to rely on when you try to access a particular field inside the structure. So what that means is this. Let me see if I still have the code in my P310 folder here. I may not have it here. So I'm going to re-download the file so I can kind of show you what I mean by that. Okay. And this is also how I'm going to test your program. All right, so let's see if I can find it here. So it'll be under my downloads folder. All right, so now I can go to my LList folder, So that means I can make any changes to this file. I can change the ordering of pnext and value. I can insert additional members. I can insert an additional member in between. Your program should continue to work as long as I do a make before I run the program. Yep, go ahead.
Why do we use double pointer to pointer in print subroutine?
The short answer is if I don't, it won't work.
Print will work without a double pointer.
Because we
The
don't
work
want
will
to
print
modify.
with a single pointer, but the reason why I choose to use a double pointer is because I want to use that so that you can learn how to use a double pointer in the other subroutines.
Second question. Maybe use printf print.
Printf.
Our assembly subroutine, we need to print integers.
Yes.
Maybe use printf.
Why do we use printf?
Maybe use printf.
Can you use printf?
Yeah.
Yes. Well, your code is supposed to be a translation from the C code. So whatever the C code specifies, you basically just translate that into assembly code. So in the C code, it's using printf
Yeah.
on line 24. So you can go ahead and call printf. So what you need to do is to do a strict translation of this particular line when you get to that point. Okay. So you basically push the value that you're trying to print on the stack, and then you push the address of the format string, and then you call printf. Just like doing any other subroutine call in assembly language.
Yeah.
So when it returns, you should clean up those bytes of the parameters, but you should do the same thing regardless.
I just check if you expect us to write like this subroutine to transfer integer to strings.
Oh, no. Well, if you feel like doing it, I'm not going to stop you.
Will we get extra credit if we do?
I think I might have sample programs already posted somewhere that can do base conversion of any base to any base. So, you can just copy that code if you want. But you can certainly just call printf. There's no reason why not to call printf. Okay. I think I have illustrated in this class, one example of using printf from assembly already. So you can just kind of copy and paste, some portion of that code. I think I did scanf, or did I do printf?
You did scanf.
Scanf, well, close enough.
Yeah.
All right. So are there any questions about the homework assignment as far as this part is concerned? Okay, but I got distracted from what I really wanted to talk about initially, which is, I should be able to come here and I can just add, XYZ 23 characters here, and your code should not be impacted at all. Okay? If you use the make utility program to remake the executable, any changes to the header file in C should automatically trigger the include file to be to be freshened, and then when that is freshened, as long as you refer to the proper label names and not to use the constants, your program or your code should be insensitive to the relative position of the members inside the structure. I'll show you guys exactly what I mean by that. Okay. So here's this program, and I'm going to do a make, and you can see how it is remaking main, and it is going to make node is not affected in this case. Okay, let me see what is going on.
I noticed that it doesn't regenerate the node.inc file. Like I deleted it once with a make clean, and it wouldn't regenerate it until I did it manually.
Okay, so that means main make node.d is not correct. It is correct. It shows that node.inc is a part of that, but I did not make an association between node.inc and node.h. It's not making that association. Okay, so node.inc depends on the generator, and then there's no dependency of the generator itself, and that's why it's not remaking it. So what I need to do is to specify. Okay, so this is something that I'm going to have to republish to all of you. So when I'm done with this make file, I'm going to upload it to Moodle in a few minutes. You will have to download the new version of the make file, and that way it will be automatic. So because I have to make this, so it depends on the, so this one has to be kind of like handmade. This rule has to be somewhat handmade here. So this is a .c, no .h. Okay, so it's complaining about line 10. Oh, okay. There we go. Okay, so this time it does. Okay, this time it works. So let me just double check and make sure. I touch node.h and then just remake, and you can see that once I update the timestamp of node.h, it is recompiling main.c because node.h also contributes to main.c. But at the same time, it's remaking the file that is generating the include file. The include file itself is now regenerated, and when that is updated, it is also going to automatically remake make node.o and anything that is dependent on the include file. So that part is correct. So what I'll do is I'm gonna tar So I'm going to create a new file for list and upload it right away. So this way I don't forget to do it.
You'll have some of us email you about it. I said, oh, someone will email you about it.
Oh, I can make a change here. So what I'll do is I'm going to change the linked file itself. So if you have downloaded the file already, you can still copy and paste or copy the file that you have worked on over to the new file. But the make file is going to be new. You need to rely on the new make file and also the file that is generating the include file. So those two files you should copy over to your project. The rest you can just keep.
Maybe just make it a separate tar with just those two files?
Yeah, maybe I should just do that. So one would be the make file itself, and the other one is node incgen.c. Yep, those two files are the ones that I update. There we go. So this way it will not overwrite any of your own files, and you can just download it, expand it, and overwrite the files that you have worked on. The make file, you might need to redo some parts of it if you have changed it already. So here is the updated make file and node include generation.c. And make that hyperlink. I was using Chrome in the other lab, and the response time of Chrome was so slow, it is as if I was using a 386. I have no idea why though. This file only contains the updated files. There we go. Save it. Make sure I forget to save before I move on. There we go. All right. So do we have any questions at this point about the homework assignment regarding the makefile, the infrastructure? So I think I fixed the infrastructure at this point. Okay, here's some questions. Can I answer those questions? Okay. All right. Are there any questions about how to work on this homework assignment? Questions?
I mean, is there a convenient way within the program, maybe just with comments or something, of keeping track of how many levels of indirection you're currently dealing with things?
Well, that's a good question. Okay, so the question was, the question is there a convenient way for us to keep track of how many indirections we're dealing with? Okay,
So what I'll do is I'm going to give you an example program that is completely fictional, that may have nothing to do with your homework assignment, but then it might. So I'll leave that connection up to you guys, and I'll just work on the sample code. Okay. So let's just say that I have a struct here, and I'll just call it struct x. Okay, there's no particular need to name the structure itself. So within here, I will have struct x, and ptr is a pointer to a pointer, so I call it a pptr because it's a pointer to a pointer to a struct x here, and I'll just make it have certain fields like int I, and so on. Okay, float. Yeah. Okay, there we go. All right. So here is a structure that has a pointer to a structure of x. It has an integer. It has a floating point field. And what I want to do is, for no particular reason, this is what I want to do. So here is a subroutine. I'll just call it make x here, because it's going to make a struct x. And what I pass to this particular subroutine is struct x pp pointer to a pointer, like so, pptr. Okay. So what I need to do is to say, whatever pptr points to, is going to be casted to struct x pointer to, and then I use malloc to allocate storage for the size of struct x here, and that's all I'm going to do. Okay. And let's do one more thing. Let's do one more thing here. So whatever pptr points to is going to be a pointer to a struct x. So with that, I can use this notation, the pointer notation here, and basically say I want that particular integer field or the pptr field, doesn't matter which one. Let's just say the I field here, the integer field, to be just 0. Okay. So those two are the things that I want to do, and I want to figure out how to do this in assembly. First of all, I need to check the types. It's all matching, working out. In this case, malloc is going to return a void pointer, and I have to pass the void pointer to something else in order to do the assignment. pptr is a pointer to a struct x, so one level of the reference turns it into a pointer to a struct x. Is that making any sense? So, and this makes sense to be a struct x because I'm allocating the size of a struct x here, so it is returning a pointer to a allocated chunk of memory that is just the size of a struct x. So the first line works out in terms of types. The second line starts with pptr here, and this is I'm actually illustrating how to read this code because the highlighted part is what I'm paying attention to, and I'm working my way from inside here to the entire expression. So pptr is a pointer to a struct x. That means the dereference version of that is pointer to a struct x. The pointer to a struct x means it is pointing to a struct x, and so I can use the pointer notation to basically say I'm not interested in the entire structure that is pointed to by whatever this pointer is pointing at. I'm only interested in one member of that entire structure, which is the member I. Okay, so I think the type works out as well in this case. I can do a type checking pretty easily in this case. I just put it into a C program. I just have to compile the program using a -C option, which means it's not going to be linked to anything. So let me just double check and make sure, because sometimes I make mistakes and I don't want to pass it on to you guys. So I'm just going to name this fictional.c. This is actual C code, okay? And it's going to complain about malloc because malloc needs to be coming from an include file, a header file. So that's in stdlib.h. And I think the rest should work out just fine. So let me just save the program, switch back to my command line here, gcc-c fictional.c. It all works out, so the types are matching just fine. Okay. So now the question is, how do I implement that particular subroutine in assembly? Okay. How many people think this is remotely related to the homework assignment as opposed to not related at all to the homework assignment? I have no idea why Tech is talking about this kind of stuff. Okay. All right, so what we'll do is we'll go ahead and I'm going to copy fictional.c into a different file. I'll call this fictional.uppercase s because that is the assembly source code that I'm going to work on. And I will work on fictional.uppercase s, turn on your line numbers here. And instead of commenting out using some tricky means, I'm going to substitute the beginning of each line with 2 pound signs. And what that will do is it will make sure that the C preprocessor doesn't do a single thing, because the C preprocessor doesn't process anything after 2 pound signs. Okay, because you use a pound sign to escape a pound sign as far as the preprocessor is concerned. So 2 pound signs basically means, okay, don't pay attention to this line at all, even if you are the C preprocessor. All right, so struct X really has no equivalent definition because in assembly language we do not have types. On the other hand, I can define displacements to individual members of this particular field. So in this case, I'm going to define all of those things by hand, but in your homework assignment, you're not going to define those things by hand because I gave you a program that can output and spew out the offsets to the individual members automatically. So in this case, I'm going to say, x underscore pptr gets 0, x underscore I gets x underscore pptr plus 4, and we have a float here, which means x underscore f is x underscore I plus 4. Are there any questions, as far as how these particular labels are defined? I use a relative way to define them, so this way, if I want to define something before pptr, it's an easy fix. I don't have to redefine every single one along the way.
The ODP or ODP address say that the ODP address now ODP equals 0 record address.
It is not yet. This has nothing to do with ODBP. This is just strictly defining the size of the structure and the displacements into different members of the structure X. Okay. And you don't have to do this by hand. As I said, you have a program to do this part here. And then I have a x size to indicate the size of a struct X. That would just be x underscore f, which is the last field of the entire structure, plus the size of that particular field, and that will give me the entire size of a struct X. Now remember, when you do this, don't do this by hand, okay? You have a mechanism that can do this automatically. Now it is time to implement makex, okay? Several things. So now we do have OEBP getting 0, and just to make this more fun, I'm gonna throw in this stuff here, and I'll just say this is param1. So instead of 0 here, I refer to param1. Okay, doesn't make it any much more challenging, but it's just one little thing that I'm gonna throw in here. Return address is ODBP plus 4 because ODBP itself has a size of 4. The first parameter is PTTR, and that is directly on top of the return address. It is return address plus 4 because return address itself is taking up 4 bytes. And then the second parameter, which I call param1, which is ambiguous, is PPTR plus 4 because PPTR itself, as a pointer, is also taking up 4 bytes. All right, so are there any questions about the positive side of OEBP? OEBP is what the subroutine itself is setting up, but the return address, PPTR, and param1 are set up by the caller. Okay. Any questions about this part? I do not have any local variables, so I'm not going to use up any local variable space. But if you do have local variables, then it will be on the negative side of OEBP. Okay. Now I get into this particular subroutine here, and I can just make a label for makex. So that will just be, I'm going to export it because I know eventually I'm going to have to do this. So I'm doing this just to make sure that when you look at this sample program as a template, you also remember to do the .global to export the label so the linker knows how to deal with it. And then inside here, the first thing I do is to say makex as a label. This is the actual label definition. .global simply means somebody else may be interested in this label. That's all it's going to say. And the first thing I do is to push LEBP to save the EBP value so that I can restore that later, right before I return. Because as far as my caller is concerned, EBP should not change at all. So I need to save and restore that to make sure that from the perspective of my caller, EBP has never changed. Is that making any sense? Okay. All right. So the next thing we do is to move ESP into EBP. So we are basically making a snapshot of the stack pointer so that we have a stable and non-changing point of reference from here on. Okay. So at this point, since I don't have any local variables, I can now start my actual code. If I do have any local variables, this would be the time to allocate.
Would the object you create within the function be considered a local variable?
No. Well, it doesn't have a name, so I'm hoping that I don't need a local variable. For the most part, in assembly language programming, if you do need some space just to store something, like I got this result here, but I can't use it right away, I have to do something else, you can just push it on the stack and then pop it later on. So there is certain parts of the code where you can do it easily in assembly without using an additional variable. But in C, you might have to use, you might need to actually declare a local variable. In this case, because the C code itself does not have any local variable, that tells me that in assembly, I probably will not need one either. All right. So what I do is I'm going to copy and paste this code inside so I can interleave my C code with the assembly code. So there are 4 lines here, and I'll just copy and paste these 4 lines over here. Let's deal with the first line first. Okay, on the first line, it looks like it's a complicated thing, but what is the order of operation here? It's an assignment operator in C, which means I have to evaluate the right-hand side first. Whatever value it gives me, I use it to update the left-hand side. So once we understand the operation of an assignment operator, that means I have to deal with whatever is on the right-hand side first. Okay, I'll deal with left-hand side later, right? But first of all, I'm going to deal with the right-hand side. On the right-hand side, you can see quite a few parentheses. So should we work our way from the outside in or from the inside out? From the inside out. So the innermost portion is what? It's a struct X, but we can't really do anything about struct X because it is a type, and in assembly language programming, we do not have types. But the outside of struct X is the size of. So we're trying to figure out how many bytes we need to allocate for a struct X construct. Do we have anything related to the size of a struct X?
Yeah.
We have X underscore size, okay? That will be the label that I define to tell me how many bytes a particular size of that needs. And it is serving as a parameter to malloc, okay? So how do we pass a parameter like that? Okay, so we have push L, X underscore size here. Would that be correct? What is this pushing? It is not an invalid instruction. It is just not what we want at this point. What is this actually going to push? We need a $sign, but without a $sign, what is it actually going to do? It will go to location 12 in this case, I think. So we go to location 12, grab 4 bytes from location 12, and push those 4 bytes on the stack. Am I interested in the 4 bytes starting at location 12? Can I even access location 12? So that means if I attempt this instruction, it's going to cause a segmentation fault right there. Okay. So now I need to put a $sign in front of it, so that I'm actually pushing the number, the actual constant 12 on the stack, as a parameter to malloc. And once I have the parameter on the stack, I can just call malloc. And calling malloc is just call malloc. There's no tricks to it. There's nothing tricky at this point. When malloc returns, the parameter that is now on the stack is not useful to me anymore. So I'm going to clean it up. Cleaning it up simply means I move the stack pointer by 4 bytes, just so that I move the boundary between the allocated portion of the stack and the unallocated part by 4 bytes. Okay? I'm not popping it because I'm not interested in this value at all, so I'm not going to pop it. I'm just going to change the stack pointer so that I'm making these 4 bytes available again on the stack. Are there any questions at this point? That's pretty much the right-hand side of the assignment operation. What about the typecasting? Struct X, asterisk. We don't have to worry about it because in assembly language programming, there is no type. Okay, so typecasting doesn't do a single thing. What malloc returns, I need to store that into whatever PPTR points to. Okay, so I'm gonna give you the wrong instruction first, and then we'll see why is it wrong and how do we fix it. Okay, because the first thing we might want to do is to say, well, since malloc it is returning a pointer, and when it is a pointer, a 32-bit integer, or anything that is a scalar, it is returned through EAX. So that means when malloc returns, we have EAX storing the return value already. So that means I can store the result right away. I can just do a move L %EAX to, hey, I know how to get to my parameter through EBP, like that. What is that actually going to do? Well, first of all, is it going to crash? Nope, it's not going to crash because it's going to modify the parameter itself. In other words, this instruction is doing this in C. It is basically saying PPTR equals malloc, blah, blah, blah. Okay, I'm not going to copy and paste the entire right-hand side, but it is going to change the parameter PPTR itself. It is not changing what PPTR is pointing to. So we wanted to change whatever PPTR is pointing to. How do we fix that problem? Put it into a register, and then we use the indirect addressing mode. What if I tell you can only play with EAX? EBX is not available to you. ECX is not available. EDX is not available to you. We only have one register. Yep. You use a stack to save something that you need later on, and then you have the register available. So I'm just go ahead. Okay. So I'm going to just make that assumption that EAX is the only register you can use. So if EAX is the only register you can use, this is not going to be much more difficult because I'm just going to save the return value of malloc first. And then what I'll do is I'm going to move L, and this time I'm taking PPTR, which is my own parameter, into EAX. So at this point, EAX is PPTR. I don't want to store into PPTR. I want to store to whatever PPTR points to. So the next instruction is just pop L into whatever EAX points to. Because I just saved the return value of malloc on the stack on line 31, so when EAX has the pointer pointing to where I want to store the return value, I just have to pop into that location. So I'm combining a few steps into one. But this is kind of like, I can do this without using any additional register. I just use EAX by itself. Are there any questions? This is the entire code for line 26 as a line of C code. Let's take a look at line 35, because line 35 has its own challenges. Okay. On line 35, the right-hand side is not the challenge. The right-hand side is simply referring to a parameter of this particular subroutine, and we know we can get to it anytime we want to. It is just param1, open paren, %EBP, close paren. Okay, so that's not the issue. The real issue is on the left-hand side. How do we do that, asterisk PPTR in parentheses, and then point to I? Okay.
Just like we did here, asterisk PPTR and plus.
Say again?
We just did asterisk PPTR in parentheses.
Okay, EAX is a pointer to the pointer itself. So we are still one level away in terms of indirection. It's not ready yet. Okay, so let's think about what EAX contains right now.
But in C we have equal stuff. PPTR with star in both lines, so it should be equal.
Okay, what do you think EAX has at this point?
I think
EAX as a register is still PPTR. I didn't change PPTR. I changed what PPTR points to.
Uh-huh.
Okay. Yep. Go ahead.
Could you just temporarily push it on just to slide ESP?
I think one picture will help. This one. And I apologize to people who are watching the YouTube video right now. I pre-apologize because they won't be able to see this.
So the reference.
Am I really sorry?
No.
Who knows?
Being sarcastic, sorry.
Yeah, go ahead.
Wrong to compile to parentheses PTR. I mean parentheses PTR.
Let's take a picture first. Let's take a look at the picture first, and then we'll try to figure out what to do at this point. Okay? So what we have here is PPTR as a parameter. It is sitting on the stack somewhere. My caller pushed it on the stack. That thing is pointing to what? It's pointing to this thing, isn't it? Okay. And on line 33, I copy my parameter PPTR to EAX. The pop instruction does not change EAX. It only changed what EAX points to. So that means at this point, EAX is also pointing to that same place.
So move EX in parentheses to EAX.
Right? And well, there are a few things that we have to do.
And head of set.
Yep.
Why do we have this written in the register? Why don't we just like pop where do you use the double bracket? Do you use double bracket?
Say again.
Do you use the double bracket?
Double parentheses. I will leave it up to you to try.
Well, the value that we want to get out is only 4 bytes away from the address that is contained inside of
We
it.
don't know whether it is really 4 bytes or not. We just know the displacement is represented by the label x underscore I in this case.
But I'm just saying we could use it this way. What I'm getting at is we can use it
Yes,
like
we
this.
are close, but we can't do it on EAX yet. Because EAX is not pointing to a struct X. EAX is pointing to a pointer that points to a struct X. So we are one level away from being able to use the base addressing mode. Okay? Because EAX is a pointer. It is pointing to 4 bytes, and those 4 bytes is the address of the structure. So we can't use the base addressing mode on EAX at this point because it is not pointing to a structure. Now, it is not difficult to make EAX point to this structure here. Because in order to make EAX, let me choose a different colors so that I can show you the transition of what we're doing here. And by the way, by going through this example, I am actually helping you this is actually going over the final exam as well. Okay? Because the final exam will have questions like these. One thing I know for sure that you will not have is I will give you the C code and you do it in assembly. Because those questions will kill me before it kills you. It will kill me. If those questions will kill you once, it will kill me like 55 times over.
You got the youngest do it with paper and pen. You let them use a computer.
I have to have the lives of 6 cats just to survive this class. Yeah.
I feel like that's a knock at collectively how well the class programs in assembly. I'm right.
Well, I'll put it this way. From looking at the answers of question 5 of exam 2, I got a lot of ideas for the final exam. I'll just put it that way and
Is that a good thing or a
stop.
bad thing?
Huh?
So is that a good thing or a bad thing?
From the perspective of of generating. Okay, let me finish my original point. Okay, so if I'm not asking you guys to write actual code to implement C code, what am I gonna use to test your knowledge of assembly language programming? I will give you assembly code. I'll give you the C code. I'll give you the assembly code. Except the assembly code has all the fun stuff that you guys will make, as mistakes in the previous exam. So your job is to go through all that stuff and fix them. So that makes my job a little bit easier because I know exactly which line needs to be changed what, how. And I can just look, okay, somebody could not see this. Yep, that's okay. Let's check, and so on. That's what I'm going to do. Is I will give you the C code, I give you the assembly code, and in some cases the assembly code is incorrect and you have to fix it. In other cases the assembly code is correct, but in those cases you have to tell me what the program or what the subroutine is supposed to do. So that's how the final exam is going to be set up.
All right. Straight before coming time.
Okay, so here's EAX.
That was your mistake.
I want EAX to point here. So the question is, how do I get EAX to point to here initially, and now I want EAX to point to here? You got the answer right already the first time. Okay. So the first thing we need to do in order to accomplish that is to do a move L, open paren EAX to EAX. I'm copying whatever EAX is pointing to back to EAX. But that's okay, because EAX is pointing to a pointer that is pointing to the base of a struct X. Now EAX becomes a pointer to the base of the struct X inside. Okay? Okay, I'm going to use special notations here.
Oh, we don't have a third color?
There we go. But that's an important transition. This is an important transition because I am now one step closer to my answer. So the next thing I want to do after this one is I am not going to change the base of the structure because I'm only interested in one part of the structure that I want to change. The C code specifies that I'm only interested in the member I that I want to change. So at this point, I'm almost set up already, but I can't do it just yet, okay? I cannot do this just yet because I can only play with one register. Remember that one additional constraint that I placed on myself, that I can only play with EAX. So if I'm using EAX like this, and I can only have one memory operand per instruction. This is one thing that most people forgot in the previous test, is when you use move or add, you can only have up to one memory operand. You cannot have two memory operands in one single move instruction. So if I cannot have two memory operands in one single move instruction, then I have a problem because I don't have another register to play with either, because I'm putting that extra constraint on myself and say I can only have one register EAX to play with. So this is also when the stack becomes really helpful, because what I can do at this point is to say I will push the source, what I'm copying from, on the stack first. So this is going to be param 1% EVP. I push it on the stack first. But when I pop it, I will pop it into x_i as a displacement, and then use EAX as a base register. That will do the trick, because EAX is already pointing to the base of the entire structure. So by using the base addressing mode and using x_i as a displacement, I can now just say, oh, okay, by the way, I don't want to change the beginning of the entire structure. I want to change the 4 bytes starting at that particular displacement from where EAX points to. Yes?
Can you just add the shifter?
Can I add?
Yeah, to EAX, like add long parameter EAX, and after that the reference again.
Yeah, you can do something like that. Okay, so this is one alternative, and there are other alternatives too. So I'll just mark one as alternative 1, and if you want alternative 2, alternative 2 will involve 2 instructions, because you will have to add x_i to EAX, and then you pop it into EAX. So that's alternative 2. If you want to use alternative 1, this is how you do it. If you want to use alternative 2, this is how you do it. There we go. So if I have a macro called use alt1 it will use line 39. If I do not have that macro defined, it will use lines 41 and 42 instead. That's a C preprocessor kind of thing. It's really helpful too. Conditional compilation is the name of this particular feature. It is actually very useful depending on what you're doing with your source code. Yep.
I didn't have line 37 and 42 at all, so
Why don't you
37
have-
I add to EAX, and after that do like 36 again, EAX to EAX.
That's because both indirect and also the base operand, they're both memory operands.
No, I mean, I don't use stack to access I.
But if you don't use the stack, how do you get around the source to copy from? That you copy
The
from?
reference again, move L EAX to EAX again, but I increase EAX before it.
You increase EAX before.
So I did add L, line 41, instead of 37.
Okay, hold
And
on.
after that, doing again 36.
Okay, say it again.
Instead of 37, line 41.
Instead of line 37, we use line 41.
Mhm.
Okay.
And after that, line 36 again.
So after line 41, what do we do?
Again, line 36.
So we put line 36 here. But then we're not copying from param 1. You're not getting to param 1.
So probably I add 2 times. Param 1 and second and XY.
The problem is we only have, I'm putting that extra constraint of using only one register,
I work with EAX.
EAX.
Yeah. So I calculate address in EAX. And
Okay.
after that, the reference is like line 36.
Okay, I understand you can store the address in EAX. Okay, the effective address you put into EAX. But the question is, how do you, in the same instruction, refer to param 1 and indirect EAX at the same time? You cannot have an instruction to do that.
I calculate address in EAX, and use like line 36.
Okay, so let me save this first. And we'll write the new file as alternative1.uppercase s, and now we're using the new file. Okay. All right, so tell me what you want to do.
As I said, instead of line 37, I add all these offsets until I reach my parameter, like I in our case.
Do you want to make the changes here? Are you sure?
Maybe I'm wrong.
Okay.
So-
Because I don't see how you can use a single move instruction to accomplish this, because
I think he's saying use 2 move instructions.
okay, so go ahead, give it a shot. Okay, tell me which lines you want to delete first. I want to get rid of the lines that do not matter. So let's get rid of alternative 1 because we only want to consider one alternative in this case. So at this point, how do we want to change it?
Yeah, let's go ahead. Sorry.
Okay. Well, you can do this in the lab. I mean, you can definitely give it a try when you're in the lab. Okay, so are we okay at this point? I mean, because I'm gonna switch back to my other file because that one is I know this one works. Okay, I know this alternative works. So are there any questions about this particular solution? What about taking the address of something like that? In other words, what if I change this program and add one more really, really insidious line here? Okay, so we'll just copy this line and say, you know what, Tech, I'm gonna add one more thing to it, just to make the program slightly more challenging, like this.
That's
Okay.
exactly what I mean.
So I'm gonna say, let's do a scanf, and I'm gonna read an unsigned number in base 10 into the address of that particular field. Okay? So we are almost doing the same thing, except this time I'm not interested in the value of I. I want to pick that address and push it on the stack.
we are pretty close to that already. We almost got it done, right?
How do we do this? Now, this is almost done already because the left-hand side of any assignment means that we have to compute the effective address first, and then we can store something into that effective address. So that means in the previous line, we had the effective address computed already. So we can go through the same process to compute that effective address, and this time I don't need to store something directly into what that points to. I just need to push it on the stack and let scanf do something about that address, or the location of that address. Okay. Am I making a point or not? Not really? Okay, let's just go through this step by step. Okay. So we know that we have to start with PPTR. How do I know I have to start with PPTR? It just has to do with the order of operation, right? We have to start all the way from PPTR itself. Okay, so I'm going to use a move out instruction here. What is EAX at this point? EAX is the same as PPTR, the parameter. Is that okay? At this point, EAX is whatever the parameter points to, because I just did one level of dereferencing. Is that okay? All right. Now, this time, at this point, EAX is a pointer to a struct X already. So if I say add L $x_i to EAX, then EAX becomes the address of that particular field already. Okay, so at this point, EAX is the address of is that I'm missing one indirection. Okay, EAX is a PPTR. This is a struct X pointer to a pointer. This one is a struct X pointer. And when I do this, it is correct. It is an integer pointer. Yep. So now it becomes an integer pointer. And what do I do with the integer pointer? Well, look at the C call here. Okay, I just push it on the stack. Yep, exactly. Just push the address of the integer pointer on the stack, and then I have to push the format string on the stack too. The format string, I can't really do it, inline, because I have to define the format string somewhere else. I'll do that later. And then we call scanf, and then we basically adjust the stack pointer by 8 to reclaim the space used by these two parameters, and I'm all done. So the way I define FMT is, well, we can do it over here. We can do it, any place other than within the subroutine itself. So FMT, is a label, and where we go here, we just say, FMT is .asciz, which means it is no terminated as a string. And then we can just put in, exactly what we want to specify, which is %u, and that's it. Okay. It's the same process as last time. I copy PPTR into EAX. EAX is one level away from pointing to the base of a struct X. So I move indirect EAX to EAX. That makes EAX points to the base of a struct X. Once EAX points to the base of a struct X, if I just add the displacement of a particular member to EAX at that point, it becomes the address of a member of a struct X, which is what I need to pass as a second parameter to scanf.
So you know how the struct X has a field for a pointer to a struct X. How
Yes.
would we populate that?
That's
the
a
same?
remember it's a fictional
Right.
structure. So to populate it, it is still 4 bytes, okay, because it's still a pointer. So the question is, what is the meaning of those 4 bytes? What am I going to use it for? And that is, since it's a fictional structure, I don't really have any particular way of using it.
Okay.
Now, one particular way to use it, I'm not going to make this any more difficult than it needs to be in this class. Okay, so if I look at fictional.c here, one way to look at a pointer to a pointer is it is an array of pointers. Like that. So that means this structure does not point to one other struct X. It has an array that points to multiple, basically child structures or substructures. Unlike a linked list where you point, one thing points to another one, that thing points to another one. This time I have one thing that points to an array of pointers, and then each pointer in that array points to a struct X.
Okay.
Well, I'm getting some really bad ideas for the final exam.
Yay.
But this is one way. But you guys know that an array is not really different from a pointer in C. It really is the same thing. It's a good thing because it allows you to do a lot of fun stuff, interesting things that would not be possible otherwise. But it's also a bad thing because now a double asterisk, which is a pointer to a pointer, can also be seen as an array of pointers. Question? Yep.
By fun stuff, you mean sadistic final questions, right?
No, I mean final exams that will kind of test whether you understand how to do the conversion or not. It depends on perspective, yes. But it is my job to assess, how well you guys understand this stuff. Okay. Well, since we're here, we might as well kind of talk about that too. Yep, go ahead.
I was just gonna let you know your make file still doesn't work. There's
The
one
make
more
files?
edit- Yeah, there's one more edit you need to make.
It does. The first thing you make, you still have to make it independently. Can you do a make node.inc and make it
If you do
first?
that line where the %.d %.s, if you add the node.inc there,
Mm-hmm.
then you can run make clean, then make just fine.
Right.
So another edit it needs to make.
Okay. So let me point it out to the class first. Okay. So in list, okay. Let me just make a make clean first, and then do a make, and then make again. Can I make that by itself? Nope. Okay, so this is one more modification you guys have to do, which I really don't like, because it defeats the whole purpose.
Yeah, that line. Space.
Yeah, if you do a node.inc or use the variable, that will work.
Yeah.
Because it's forcing the dependency. It's basically saying that you need that in order to create the file.
Yeah.
So it's forcing the generation of the include file first in order to make that dependency file. It's not a clean solution, but at this point, I will settle for this solution first. So this is what you need to do to the make file to make it make after the clean, is to put percent, dollar open paren inc here, close paren. So this time, if I make clean, make plan, make clean, make again, then it works. Right. So we got 15 minutes left. Okay. So what would be some of the other questions that you guys have for the final exam? This is one long practice question, by the way.
Just to clarify that one question of a few.
Well, it illustrates the main concept that you guys need to understand on top of what we already have tested in exam 1 and exam 2. There won't be any finding types of questions because we are pretty much well past that point in terms of understanding addressing nodes and stuff like that. But instead will have questions that are looking at C code and looking at the implementation of the C code. Because that really is the emphasis at this point, is we look at the C code, we look at the equivalent assembly code, and then we say, is this actually doing that? Or if this is actually doing that, what is it really doing? Yep.
Are there opportunities for expert?
Say again?
Opportunities for expert?
Well, that is a tricky question, because if I give you guys, a chance for extra credit, that won't be easier than the non-extra credit questions. I will think about it. Okay, I learned from experience, not just making promises.
You said that last time during the meeting.
And I'm still thinking about it. I kept my promise.
Thought process keeps going on.
Yes. Well, my best friend, who lives in Livermore, he's a really smart guy. We used to play, chess, like the Go game and stuff like that. And he would think when I'm thinking, he said that he can hear my brain working because it sounds like a stone grinder grinding. It's like, so yes, I'm still thinking. Yeah, it's still grinding, yes. What is grinding, I don't know. Okay, but my inclination is no extra credit, but I'll try to give you guys as much help as possible to clarify these concepts so that you'll be ready to answer those questions. The homework assignment is designed so that you guys have to think about these concepts in order to get the homework assignment done. And if you understand these concepts to get the homework assignment done, you will have the knowledge, and the ability to apply that knowledge in the final exam. Okay. Let me just go back to the source code and let me ask what makes this particular type of what makes this kind of code not easy. Okay, so I'm going to look at a particular line here. Okay, I'm just going to look at line 25 here. Okay, so I'm going to look at print list. And my suggestion is to implement print list first before you implement insert into list. Okay, because print list is a little bit easier. Okay, it does not have all the conditions of the other one. So when you look at line 25, how do you get started with this one? I mean, given what we have talked about today, it does look awfully like one of the things that we talked about today. I'll shut it.
There you go.
You have to think about it, you have to draw a picture first, okay? Draw a picture, find out what the parameter really is, and then we figure out, okay, how do I go from what the parameter is specifying to what plist is specifying so that it becomes the parameter that print list is expecting. So we basically go through the same thought process that I went through today.
Well, in that case, what it's asking you just to do is it goes to the node that plist is pointing to, right? Like it wants you to move on to the next one, right?
In fact, to test this program, okay, when you implement print list the first time, I would not even go through the entire thing. I would implement from line 19 to line 21, and I stop. In other words, I just look for the base case to print an empty list. That's all. And you do not give it a list that has anything. You give it an empty list. You make sure your subroutine can return properly in that case. Okay. That will be the first thing that I do.
And then once you do that, you just have to make it.
And then once you can do that, then you give it a list of one single item and not do the recursion. In other words, once your subroutine can identify an empty list and do nothing about it and just return, then the second thing I would do is to add line 22, line 23, line 25, not line 25, line 24, but not line 25. And it will only be able to print one node of an entire list. Okay? Just to make sure that you can get to the value number of a node. Do you see what I mean? because I don't want to add the recursion part until I know I can print at least just the value of one node. Once I know that I can print the value of one node, then I can add the recursion to make it print the value of the other nodes. So that's how I would implement this program. Because what makes a programming assignment difficult sometimes is not necessarily the code itself, it is how you start and how you proceed with the testing of this program. Let's take a look at the second subroutine here. Okay? So when we look at the second subroutine, it looks like a big, huge mess. But you know what? I can still fit it within one screen, which means it cannot be too bad. And I'm using what font size here? 16 or so. I mean, we upped it. We changed the font size here. Yep.
So length of programs are now done by Fermi estimation.
So with this program, I will do the same thing here, which means I'm not going to implement the entire subroutine. I will implement only lines 31 to 34 initially. Leave the rest alone. Okay? Make sure that you can create just one item when the list is empty. Okay? And that's why I want to implement the other subroutine first. But when you implement this one, there are ways that you can actually, I guess it is a kind of a chicken and egg thing because you need this one to create a list. Okay? But you can create, what you can do is to create a list of only one node. And when you create a list of one node, you can use GDB to help you print it out. Okay? GDB can do that. Okay, you can just say print in GDB, print whatever list points to. Inside main, it will give you the structure itself. Okay? So once you can create one node, you make print list to print just that one single node. Okay, so don't do any recursion until you can do just one node. Once you can do one node, then you move on. And the second thing you can do is to implement line 35 to line 37, which basically means if I give you two numbers, two identical values, two identical numbers, you should go through that and say, oh, that's nothing to do because this node has the same value as what I need to store, so I'm going to end, there's nothing to do. So you need to make sure that your program can stop the recursion at that point and basically say, there's nothing that I need to do. Is that making any sense? So once your program can identify this node has the same value that I'm supposed to store, and therefore there's nothing for me to do, then you can move on to line 38 and line 38 to line 43, which is basically saying, okay, do I have to store something before me? Okay. Now that is actually a little bit harder because there's comparison and stuff like that involved. So instead of doing that, you can kind of forget about line 38 to line 43, and instead implement just line 44 to line 47, which basically means I don't want to keep the ordering of the numbers. I'm just adding the new node all the way to the end. So if I give you two 23s, it will only store one because we still have that check on line 35 to make sure that it stops. But if I give you 1, 5, and then a 3, it will store it in that order, 1, 5, and 3. It is not sorted. It is not what the program is supposed to do. But nonetheless, it will still kind of insert it, just anything. So I'm going to implement the program step by step, and each time I pick something that is easy and natural from the previous step. But I'm not going to move on to implement anything else until I can get a previous step working completely. Is that making any sense? I mean, anyone who's attempting to write this program from start to finish in one single stroke is either a genius or some name that I cannot use in class. Because I cannot do this. I can tell you honestly, I cannot write this particular function in one single stroke. This is exactly what I would do, is to do in steps. Do one little step, check it, do another step, check it, do another step, check it. Okay, and I will use GDB as much as possible because GDB is your very crude and basic print list. It has the ability to do it. It has the ability to do it. I think last time I illustrated how to do that already. So that's one way, one tool that you can use in place of print list as a subroutine to print the values of a list. Use GDB for that purpose. It is useful for that purpose. All right. So how many people are already using these approaches to write a program anyway and just reaching to the quiet, wasting your time? Okay, very good. Okay, but not enough hands. But this is not something that is specific to this class. When you're writing programs in your other classes, in C++, in Java, in Python, in PHP, when you go to work as a programmer, as a developer, this is still what you need to do. I mean, there's no way you can write a program of any type of actual complexity from start to finish. You have to do it in steps and make sure that you understand how to use a debugger and how to test the program step by step and build it, basically upon yourself, step by step. And you have, what, 1 week to work on this from this point? Okay. I would definitely do it step by step, because in the case that you cannot finish the entire program, if you do the program step by step, hopefully one of the test cases, a simple one like an empty list, or a list with only one item, or a list that has items in a sorted order to begin with, your program will at least work with those cases. It doesn't work completely with all the test cases. So that's the other reason why you want to work on it step by step. All right. Any other questions? No other questions? So the test is comprehensive. Okay, so whatever we have talked about throughout this entire semester is, subject to be tested. But the focus is definitely on the later part of this class, mostly in subroutines and how to convert C code into assembly code in the context of parameters, pointers, structures. Yep.
So 8 questions?
I cannot tell you how many questions yet. I have not decided on that. It depends on the complexity of the question.
So, are we gonna see Johnny on the test?
Well, I don't know yet.
Return of Johnny.
The return of Johnny. Yep.
Do you have the second exam?
I do not have the physical exams with me. I brought it along a few times, and then I just if you want your specific one, I can email you a photocopy of that. Well, send me an email and ask me. I have worked on it with question 5.
Yeah, I don't want to see a bad idea.
Question 5
Do I need to repeat it?
regarding what?
Regarding my home.